First we'll understand how to draw the diagrams. First we'll understand it. Two different ways I can teach you common base amplifier diagrams. Common base amplifier. We have two different patterns for this. In the exam point of view, I can show you in two different ways. One is a horizontal, one is vertical design. I can show you my amplifier in horizontal like this. Coupling capacitor, CC. This is my input. Next here, we'll get some RE, biasing resistor, and we have transistor. NPN if you take, this is ground, base, this is RC, and capacitor, CC to output. Here, how to write this biasing batteries? Here we need two batteries compulsory in common base. If you want to decide that, first you have to see the diode positions. This is your diode, emitter junction diode. Collector junction diode is, this is P, this is N, this is N. So we'll have, this is the style of writing the diodes. This is P here, this is N, this is N. So P and NPN transistors. This diode should be forward bias, this diode should be reverse bias we want. Then battery biasing should be done like this. Negative we have to give here, positive we have to give here. Here we get a dual battery biasing. Common base is the only transistor. We'll have two battery biasing. Because input has to bias with input, the output has to bias with output battery. This is VCC battery. So you can see the battery techniques. One is forward bias, one is reverse bias with this battery technique. So common base is the only amplifier in analog electronics which will have two battery biasing technique. Input junction will bias with one battery, that is VE battery. Output junction will bias with collector battery, VCC. So this is the different style of amplifier now. Up to now we have been spending our time with only single batteries, but the style is vertical designs. Horizontal circuits requires two batteries compulsory to bias it. So this is the way how you see in exams the amplifier. Not only this, they can show another style in exam point of view. Vertically also the same diagram I can explain like this. Vertical model technique. If I show common base amplifier vertically, it looks like this. This is RE. This battery is minus VE. This is CC. This is your input. RC. This is C. This is your output. You can see vertical design. The same structure, if you bend it like vertical design like this, it looks like this. So you can clearly observe the points. This is base here. Base is ground. Base is ground. Common point is ground. And this is your collector point. And this is your emitter point. So what is the beautiness of this concept is input we are taking at emitter now. Input should be going to emitter. Collector should be going to output. So the base will become the common in this diagram. So the same diagram you can represent like this. Both are same. You can write here. Or we can write. Both the diagrams are same. So don't get confused in the exams. Okay. Some people will show vertically the diagrams like this, where you have two batteries here. Input will be given at emitter. Collector. Same thing I done here also. So both the diagrams are same here. Don't get confused. So don't get confused in the concept. So the next will be common gate amplifier if I take. So first I think we finish the common base first. Next I'll come to common gate. Now these two amplifiers, how to write the equivalent model side by side. For this how I'll write the model, for this how I'll write the model. Vertical model how I'll write, horizontal model how to represent. You can see the diagrams. So here horizontal whenever you see, we'll go for a T model technique. AC model will be like this. This is RE, this is RE to ground, this is VIN. And next we have here R pi will be there. So T model I'm applying. This is emitter, junction point. We have here R pi, which is your base. Next we have is a current source. T model, emitter, base, collector. Collector side, we can write it as beta. Sorry. If you want to write R pi model, you can write this current source as GM into V pi. We can write GM into V pi. Next we can have some RC, and we can keep it as ground. This you can take it as output. Suppose if anybody say some early voltage is there, you can keep some resistance here, early resistance, which is R0, which will be in between emitter and collector. This is due to early voltage is not equal to infinite. So R0 is coming there. R0 is a resistance will write parallel to current source. Maybe R0 will come in the say in the exams early voltage is not equal to infinite. You have to take here. So please note down up here, just 1 minute, I'll come back. So this is the T model representation I have done. Okay. Emitter is emitter only I have taken. Base side R pi I have taken. Collector side we have taken a current source. This is called T model approach. When you are going for horizontal techniques, go for T model is better for you. But when the question comes like this, vertical, you go for Y model first. So what is Y model is simply you can write like this. Ground. We have R pi. Y model is R pi directly you write here. And we have RE in the bottom. Next we have a current source. GM into V pi. And finally we have here RC to ground. If you clearly observe, this is called Y model. From here to here, R pi are represented. Here RE will be there. This is ground. This is current source. And RC to ground. This is our general common style of model. Okay? That's why whatever you do is not the importance here. According to the given question, you try to solve it. This is convenient when I have like this. When it's horizontal, it's convenient for study. When it is vertical, this is the way it is convenient for me to study. So whatever you write, both are same in the class. So you can say this model and this model are same. Just a T model, this is just like a Y model I represented. Both are same. So don't get any tension on these concepts. Okay? Both will be same. If you want to write some R0 here, you can write R0 here. Between collector to emitter, there will be some R0. If early voltage is not equal to infinite. So this is the way of representation of your common base amplifiers. So which model they have given, according to that you take the model and solve it. Anything you can teach. Generally this model is better to calculate current gain calculations because they look easier for me. Currents will divide. So current gain calculations, I'll take that example to teach you the current gain. Remaining things I can do here directly. Input impedance I can solve directly from Y model. Output impedance I can show you directly. And what is the last concept is voltage gain. All these issues we can solve here. Last current gain separately we will take the horizontal model to finish the current gain structure, how it will come. That is the concept. Okay. That's why in the exam point of view, whenever they ask you current gain problems in a common base amplifier, they ask you like this actual problems. But if they ask you just like voltage gains or input impedance or output impedance, they can ask this or this, anything is okay. But for current gain especially, they ask you horizontal technique. Because to solve current gain, there is a convenient model for us. Okay. Let's see all the 4 characteristics how to find out. Again, the concept. Is there any matching? Okay. Is there any properties are matching with some other configurations? Like that, we'll highlight the points. Okay. Just I'll give the highlight points first, so that remembrance will be good for you. So first complete the common base, so that common gate will not take much time to analyze the circuit. Common gate will take less time. So up to here it is clear, I'm expecting. This is your IC current, so this is your IB current. This will be your IE current. It's an NPN transistor, so the current IE will go outward. If it is an NPN. If the question is PNP, you have to keep inward directions. This is outward direction circuit because of NPN transistor technique. That's why in the exam point of view, most of the times common base they give with PNP transistors, so that the currents will go in forward direction. I think your input you have to take here, my friend. Your input is here. Is there any ground? Is there input? Emitter is input. So thus input इधर ले ये input हो जाएगा, ये ground हो जाएगा. Okay, in Y model, the input is taken at emitter point, not at the base point. So let us finish this concept. We'll do the 4 derivations based on this concept. So nicely write down these 4 structures. So please draw it, just take some water. So if it is completed, let us move to the analysis now. Okay, let us move to the analysis. So you can take any model to start the class. Let us take this model side. First I'll start my input impedance calculations. So the next slide you can see. So analysis I'm doing. Analysis. I started my analysis here. We'll start your analysis here. The first point number 1. Input impedance. Somebody is asking the question to me. Can you tell me what is the input impedance? If you see the model, Y model I'm taking, this is R pi. The next we have is here RE. This RE is there. So let us take RE somewhere here. RE will take here. And we have some current source, GM into V pi. And finally, we have some resistance here. This is RC. This is your output. Okay. This is the model we have. So can I expect this point, if I take emitter point, this point is emitter. He is asking you here the input impedance. So from here if you see the testing voltage here, I'll take some testing voltage here to know the equivalent of this component, how much. Okay. This part, how much is the equivalent? First we'll find out. Parallel to RE will become your input impedance. So this is your input impedance. You have to find from here. This ZIN you want from here. But we know the trick here. This total is Rx component, which is V0. We'll take this as I0, and we'll just find out some Rx from this. If you find Rx, which is this equivalent total resistance, is already known to us. Rx is nothing but R pi parallel to 1 by Gm. Is already known to us, which is coming from active load technique. It is once again repeated, the concept. This total is Rx value. So what is the input impedance we are getting is Re parallel to Rx. That is Re parallel to R pi parallel to 1 by Gm. So which can be written as Re parallel to 1 by Gm, which can be written as only 1 by Gm. So this is the story again coming in the class. So input impedance for common base we are getting like this. Input impedance for common base we are getting like this. Yes, Majendra, for common emitter we have both bypass and unbypass. But this system, common base is bypass or unbypass. एक बार देखो. Common base is considered as bypass or unbypass. What we can call here RE is the passing concept here. Where bypass should be here. We cannot keep because it's a passing resistor. So common base can be working like a bypass concept. They are working like a bypass. Because this RE actually should be here, but it came to the input side. We don't have any bypass here. This is your base. Okay? Base side if you see, it is a direct short you have taken, nothing is there here. So it's a bypass module. This is a bypass. Unbypass is common collector. Bypass is common base amplifier. It's a bypass technique here. We don't have any CE effect there. CE is not required in this concept. That's why it is called bypass. Common base will work under the principle of bypass. So can you see that this is similar? It is similar answer. Similar to common collector output impedance. So like this you can recollect the subject, which is your Z0 1 by Gm. So this is the story of my common base. Whatever the common collector output impedance you enjoyed, the same impedance will come to common base at input. That is the way how to recollect the properties in exam point of view. So you'll have the lowest input impedance in common base. You'll have the lowest output impedance in common collector. Common collector ko output impedance will be the lowest. Common base ko input impedance will be the lowest one. Because you are finding the impedance from the emitter side. Common collector mein emitter became the output, but emitter became the input for common base. That's why the beautiness is that one. This is first two similar observations. Observation number 1 is similar like this. So let us complete the input impedance is similar to common collector output impedance. This is my first observation. This is my first observation. Similar to common collector output impedance. So this result is not a new result for me. Same result is coming. Let us understand the output impedance calculation, how to do it. Next concept is output impedance. Whether output impedance will match with any other concept, we'll try to see. Okay? Will match with any other concept, let us understand. The second concept we'll see. because here why it is called bypass means CE capacitor is not there in the diagram. We have only two coupling capacitors. There is no bypass capacitor in the problem. If there is no bypass, we can say it is unbypassed technique. Okay. Bypass means if there is anything you see here, anything if you see here, a short directly here in the middle, we don't have anything here. Okay. Any capacitor we are not kept, directly we made zero. That's why the system is a bypass technique. It's a open loop amplifier we can call. Okay. It's a open loop amplifier because RE is a bypass component which came to the input side now. That's why it cannot work as a bypass, which cannot work like an unbypass. Which cannot work like a unbypass. Just 1 minute. It is not unbypass, my friend, it's a bypass. Okay? Unbypass means RE effect should be there in the middle, but RE effect came to the input side. That's why RE is not working as a bypass resistor. Okay? RE is not working like an unbypass, sorry, not bypass, unbypass resistor. It's not there. So here you can leave it off that point. So this is the first concept. So the input impedance is always getting as 1 by GM will be the answer. Suresh Kumar, oscillators, I'll teach in the live only. Okay? I said that only 2 topics. I'll do some extra information for you. One is triple fat timer, one extra miscellaneous topic it is. You may ask or may not ask, that's why I'll give that as video. And one is active filters, complete video I'll do for you. But in the classroom also I'll teach, only for half an hour. Just a shortcut tricks I'll teach, but elaborate video I'll do as recording video separately for you. To get the good concept and good information. Remaining things I'll teach in my class. Each and everything I'll finish off. Okay? Yes, Majender, we can take, the biasing is there, we can say they are in current saturation. So last second point, observe the second point. If I go for output impedance calculation, output impedance. If I consider output impedance, that is Z0. What is going to happen if I want to solve output impedance? So for output impedance, this is ground already. We have R pi. Next we have is a current source. Gm into V pi. Just keep it collected like that and keep the load side by legs. This is load. This is RL. This is your RC you can say. You want the output impedance from here actually. You want to find output impedance. First to finish the impedance from here. That is some Rx you find out. First inside impedance if you can find, I can take parallel combination with Z0. So for this what happened is, there is RE here. You have some input here. To calculate the output impedance, the main rule is here, the input should be grounded. The input source should be ground. That is our output impedance calculation. So if this becomes ground here, can I say that there is no current here? There is no current. This voltage across this, suppose if I take this as VE, it will become 0. This will become V pi. Okay? If there is no potential from here to here, there is no potential from here to here, we can write this as the potential V pi, KVL if you apply, V pi plus VE will become 0 here. Correct? Then VE will become minus V pi. But what is VE here is, your input is VE. So your VE becomes your input. It will become 0. Therefore V pi also becomes 0. So this is the story happened. Your VE is minus V pi in the board, but input is 0 directly ground to calculate output impedance. So V pi becomes 0. As V pi becomes 0, GM into V pi also becomes 0. So the current source is open here. Current source is open. Your current source is getting open. If the current source is open here, this total is open circuit, then what is your Rx value here is infinite. Your Rx is infinite because current source is open. Then what is the value of Z0 is? It will become infinite parallel to RC. The answer will be RC. So Z0 is coming a simple answer, RC. So if you see this formula, it is exactly looking like a common emitter formula. Common emitter bypass or unbypass, we got the same formula. Okay? So this formula is valid when VA is equal to infinite. This formula is valid when VA is infinite. If suppose VA is not infinite, you can write it as RC parallel to R0. This is the formula for VA not equal to infinite. These two formulas are exactly matching with your concept. These two formulas will match with my concept called common emitter bypass amplifier. Output impedance is Z0 is equal to RC is the answer. For early voltage is infinite, Z0 is equal to RC parallel to R0 in case of VA not equal to infinite. So this is the story. Again we got the similarity in the class. Input impedance similarities with common collector, output impedance. And here common base output impedance is similar to common emitter output impedance. Like this beautifully we'll observe the points. I think they'll never forget these ideas. Tricks are very easy and understandable. Samresh, in the shortcut methods when I teach, there I'll tell you bypass and bypass difference. There I'll explain you, don't worry. In the workbook practice I'll explain you. At this moment please complete it. So the second observation is also beautiful. The output impedances of a common base will match with your common emitter bypass. They'll match with your, these two are the matching points. These two are matching points in the concept. These two are matching each other. So please complete these two steps. Last we have two more issues. One is voltage gain and one more is current gain. Let us see voltage gain also will match with any amplifier, we'll see. And current gain if it matches or not, we'll see. Two more issues. Okay, with that this story will be completed. Common base is also not a big topic, easy topic. Only thing is matching, so you have to see which configuration these parameters are matching. Already input is matching with some amplifier, output is also matching, then we have to see gains, whether they will match with other amplifiers or not. That is a small investigation we have to do it. these things happens only in current saturation techniques. So assuming that it is in current saturation, straightforward you can do the problem. Yes, Akash Mitra, if you want I can give a formula chart also, I'll explain you. Each formula side by side I'll show you. At the end of the class, I can make you that concept. Okay, I can visualize that after common base. Each formula side by side, what is the change? You can understand it, the class. Okay, no worries, the formulas will make a chart if you want. So that the concepts will become easier now. Okay, each problem can apply very quickly. Just make a chart, it will be easy for you. So please complete it. 2 more issues to end up this concept. By 12 o'clock we can complete it. 12 to 1 we'll do the practice of common base. 12:15 to 1:15. 15 minutes break. After 15 minutes up to 1:15 we'll complete the task. 2 o'clock we'll start the class today. 45 minutes only break for lunch. Okay, 2 to 4:30 we'll complete the target of common emitter and common source amplifier problems. Total concept will be ready today. No recording, directly live. We're trying to complete all the problems. So आज class, the break will take 45 minutes. In between I'm giving break for 15 minutes again for. Okay, that is the reason. So let us complete it. Let us complete. Common emitter bypass output impedance is completed. Let us see the concept number 3. Concept number 3. Voltage gain. The formula will be different or same. Try to understand. From which amplifier it will match this gain. Try to observe it. Same. I'm taking ground. R pi. This is R pi. Next we have current source. Gm into V pi. We have Re. This will be your input. And we have the load. That is RC to ground. It's a very simple derivation. Try to see. Very simple derivation. You can have a trick here that this is your input from here to here. And this is your V pi. What is the relation between these two? Seeing the input loop is by using KVL at input, you can have a link always. V pi plus VIN is equal to 0. So VIN can be written as minus V pi. You can have a beautiful link like this at the input. Now let us see the output voltage how to write is. This is your current called load current I naught. So it is coming plus minus, same like previous class. So V naught you can write it as minus I naught into RC. This is the answer. V naught is equal to minus IC into I naught into RC. But I naught is what here? It is minus GM into V pi into RC. This is the formula which we got like common emitter case. But there is one logic here. Okay. मजुमदार ऐसे नहीं बात करना यार. ओके आपको ऐसे नहीं बात करना. थोड़ा इधर क्या 50 मिनट्स क्यों ब्रेक दे रहा हूँ. ये होने के बाद सेपरेट वीडियो हाउ टू टेक अगेन. ओके ये क्लास होने के बाद वी हैव टू टेक अ सेपरेट वीडियो. फॉर दैट इफ यू टेक अ ब्रेक आई कैन मेक अ न्यू वीडियो फॉर इट. लाइक दैट आई एम मेकिंग द ब्रेक्स टुडे. सो लेट अस अंडरस्टैंड हियर वन डे. ओके 1 hour 2 hours ऐसे नहीं है. प्लानिंग अकॉर्डिंग टू प्लानिंग वी आर गोइंग. ओके टुडे at least please who is this Majumdar please 45 minutes today class break. Okay tomorrow we can take 1 hour if you want. Today these are going like a partition videos. ये topic होने के बाद I have to take a workbook video again. After that common base workbook video like that we are doing parallelization. Please try to understand it. Okay in between break is compulsory I have to take now. So this is the diagram and output is coming like this. Can you see here one trick? GM you take it as GM minus V pi into RC you can take like this. The negative sign you bring it to the V pi so it will become minus V pi. But here minus V pi is your input here directly. So answer will be GM into VIN into RC will become the output. So output by input which is called gain is a simple answer plus GM into RC. If you see this answer, you must be able to get the subject knowledge like this. A common base amplifier is also giving the voltage gain similar to the common emitter voltage gain. Both are getting same gains, but one is giving a negative effect, one is giving a positive effect. So that means it is exactly similar to common emitter voltage gain. Common emitter voltage gain in magnitude. Magnitude wise, it is same. It is similar to common emitter voltage gain in magnitude. So that is the way you can have all the formulas are related to the previous formulas. So then why can't you enjoy this formula straightforward to solve the problems gains? Gain formula is very simple now, common base. It is GM into RC. It will not have 180 degree phase shift. It will give just if they give a signal, it will amplify in phase. So we can have in phase amplifiers, we can have out of phase amplifiers in electronics. So please complete. The story number 3 is also clear. After this theory lecture, okay, there will be some 15 minutes break for you. In that break, we just relief. After 15 minutes, we'll have the workbook practice actually. This common base may not take maximum 1 hour workbook practice because less number of questions are there. After 1 hour, the recording video will be completed. So last job is afternoon 2 to 4:30. I'll take 2.5 hours to complete the remaining issues for you. Okay, that is my plan actually. So today we have a number of videos will be there. Okay, morning to evening, I think we are getting nearly 4 to 5 videos. One is common collector, common drain theory part 1 video will come. After that you will get workbook practice, so 2 videos. Next is common base theory, common base workbook, so 4 videos. And yesterday class remaining workbook video. Total 5 videos will complete. Okay, that's my plan to complete this. So Ankum Das, I think this is exactly coming. Common emitter voltage gain bypass. It's coming bypass. So somebody asked me a question, sir, how it is bypass? Means this is the meaning. If it is suppose an unbypass system, it will give the answer by 1 plus GM into RE. If it is it's a bypass, we get only GM into RC. That's why it is a bypass systems. It's not a unbypass. From the gain formula, you can understand it. From the gain formula, we can understand it's a bypass common emitter, the voltage gain magnitude answer it is. And it does not have 180 degrees phase shift. Okay? It's a positive gain, not a negative gain. Okay, Harsh Mishra, very good, great. Last topic here, that is called current gain, how to teach. And what is the formula similarity is there with any other amplifier? I'll investigate. Let us complete the final concept. That is called current gain calculations. The last topic here, current gain. So please complete this one. We'll see the last one. Current gain calculation. Yes, Roy, negative sign will be disappeared in common base. Positive sign will come here, which will tell about they are not 180 degrees phase shift amplifiers. They are having 0 phase amplifiers. Common collectors also 0 phase, and this amplifier is also 0 phase. But it will have more voltage gain, but in common collector will have unity gain. That is the difference. Common base have more gain. Common collectors will have unity gain. So let us see the final step here. One more interesting derivation for you. The last one. Fourth one. Current gain calculations we are doing. Current gain. which is called AI. Suppose if I'm teaching this concept for PNB, it is easy for me to make you to understand. Otherwise, outward directions will be inconvenience for you. But the formula, whatever you get, is the same for PNP and NPN. Now I want to teach in forward direction the concept. If I consider this as a PNP design, the current emitter will get inward, the outward will go IC, the base current will go outward. So this is the way how to write model for PNB. Let us write the horizontal model technique now to teach current gain. Simply you can show like this. This is RE. This is VIN. Next we have emitter. And we have resistance here, R pi. Next we have current source will go outward. So GM into V pi, current source. And we have here collector. This is the way you are seeing. You are giving some input. Okay. RE with the biasing ground. R pi will be there. GM into V pi. And finally here we have some RC. We have some RC. This is your output. Where you have some current here, I naught. So it's easy to understand it. The current you are entering here, this current will take it as II. This current will divide into two parts. This current will divide into two parts. One current you take it as some IX current here, and some current will take this as IE current. But this IE current will divide into two currents. One is IB and one is IC current. So this is the way the beautiness of current gain calculations. Okay. Horizontal method is better due to these reasons. Easily you can see the current pass. So now I want current gain here. So can you finish what is II first? What is I naught seeing the board? I naught can write it as simply IC. This was same, which is GM into V pi. You take it as equation 1. First I naught is completed. What is II? It is IX plus IE. This current plus this current. And you can write this as IX plus IE current can be written as IB plus IC current. IB plus IC is equal to IE. So three currents are there now. IX you can write as V pi, you can take this voltage, which is parallel to this also. So V pi by RE you can write IX current. Second current is IB. V pi by R pi you can write plus IC current is GM into V pi you can write. So we have this is the impact. So II you can simplify as II as V pi by RE plus V pi, take it common. It becomes 1 by R pi plus GM. You just take the common like this. V pi common, 1 by R pi plus GM is coming. The 1 by R pi is in kilo ohms. R pi is in kilo ohms. So this quantity you neglect it. 1 by kilo ohms value comparing with the GM value. Okay. If you neglect this answer, small value compared to GM now it is. So can I expect this quantity if it is neglected with GM? The ideal answer will be V pi common. It is 1 by RE plus GM you can write. A simple expression. 1 by R pi comparison with GM I neglected it. So 1 by RE plus GM we got. So we'll apply it. Current gain formula as simply I naught by II. Apply this formula. You take this as equation 2, second equation. So I naught value here is GM into V pi. GM into V pi divided by GM into V pi divided by V pi into 1 by RE plus GM. So V pi is cancelled. So can you see the formula how it is coming here is current gain formula structure is GM into RE by 1 plus GM into RE. If you clearly observe this formula, this is also matching with some other formula. Means the common base is a copy version of common emitter and common collectors. You have some similar properties of each configuration what we studied till now. I think this formula is exactly similar to a gain, voltage gain of common collectors, which is called a buffer. It's like a voltage buffer is coming. In common base, it is looking like a current buffer. So in analog electronics, we have voltage buffers, we have current buffers. If you want a current buffer, we go to common base systems. So it is similar to common collector voltage gain. Common collector voltage gain. Whatever the formula you got in common collector voltage gain, the same formula will get for common base current gain. So that is the way how to remember. Now the trick is if GM into RE is much greater than 1, your current gain will become 1. That's why they are called as current buffers. Current buffer. So a common base will behave like a current buffers in electronics. So this is the complete package of your subject. I'm showing each and every derivation also for you so that your thinking will get enhanced to understand this analog electronics. You can see how the birth came for these formulas with a simple AC model analysis. So finally, these are the basic things we should rotate in your mind always to do these analog questions very easily. A common collector is a voltage buffer. A common base is a current buffer. Whatever the buffer formula you created in common collector will be same as common base current buffer formula. Both will be the same. So nothing to forget the formulas. Okay. In the short notes, I'll show you the formulas now how to practice. In common base short notes, I'll explain you total formulas at a time. So we have completed. Just give me 5 minutes to complete that final issue called MOSFET common gate amplifier. Just overview, I'll tell you how to write that model. Yes, here Vishal, buffer means that only here input should be equal to output. But in terms of current, if it is equal, we call current buffer. If input output is equal in terms of voltage, we call it as voltage buffer. A common collector is a voltage buffer. A common base is a current buffer we are getting. But the current buffer does not have the rule that input impedance should be high, output impedance should be low. Only for voltage buffers we have the properties, not for the current buffers. Yes, stability thus 1 by R pi is very small value. That's why I neglected it to make the formula simple for you. Okay. Otherwise, it will take complications for you. Formula will be enhanced. That's why to make it the easy formula, R pi to neglect the concepts. Only GM will be considered in the formula. So let us complete the final slide, which will finish our today. Okay, common base and common gate amplifier analysis. After that, we'll attack the workbook problems by taking some small break. We'll complete that. So let us see the final issue. That's one. That is a common gate. How to write the answers, the similarities. Akash Mitra, that is not the meaning. Common base for current buffer aya. That is not the meaning that we have to use current buffers. Okay. Current buffer is a principle. Will happen in some subtopics like cascode systems tomorrow classes. Okay. There you'll see the importance of a current. Current transfer ratio. What you get is 1. That importance you'll see in the next topic is called multi-stage techniques. There you'll understand it. Your only idea to use that tomorrow class, we'll get the stories. But application, I'll tell you where to use this. Last one, keep the heading, final concept, common gate amplifier. Common gate amplifier. So don't get much pain in common gate, no, it's easy now. A particle model I'm showing. Take MOSFET with RS, with minus VSS battery, coupling capacitor, we have input, and we have RT, this is VDD, we have coupling capacitor to input, to output. This is your common gate amplifier. Okay, if you write the model, AC model for this, AC model, presentation. This is gate source, we have VGS, we have RS, we have current source, GM into VGS, parallelly we have RT. You can see how much easy this answers now. Very, very easy answers. So this is the model you have seen. If the question came in MOSFET. Now the point is, what is the input impedance? Seeing the board, you have write these answers. This is source. So if I want the input impedance from the source, it is well known, I think, answers. It is RS parallel to 1 by GM. So this is the input impedance. Always remember, inside is 1 by GM from the source, from accurate concept. This was coming from accurate knowledge. So one time if you are perfect with the accurate, is a bypass or unbypass. I already proved in the previous concept. We got the gain formula like this, GM into RC, which is coming similar to the common emitter bypass. So common emitter bypass gain is coming here. That means what? It is a bypass system. It's not a unbypass. With respect to the formula, you can tell that whether it's a bypass or unbypass. Okay? It has to match with the bypass or unbypass formula. So the last one, output impedance. If you want output impedance from here, the output impedance simply it will be RT. RT will be the output impedance. And what is the voltage gain? It is simply plus GM into RT. So this is called bypass gain. So this completes the derivations. This is my bypass gain. This is my accurate input impedance answer. This is my load. So this much easy the parameters. So this completes the story about the common gate and common base amplifiers. So where to use these amplifiers? I'll give a small application for you. You'll just write the application below this. Application where we use this. Common base or common gate amplifiers have high bandwidth. Common base and common gate amplifiers have high bandwidth. So they will be used for high frequency applications. So this is the main importance of this. So common base or common gate, generally whenever you go to very high frequencies, common emitter systems will have less bandwidth. I put in my previous class. It is giving less bandwidth, which is F beta. F alpha is common base, which will have very high bandwidth, etc. So common base can be used for high frequency applications. Not more than we have the importance about common base. Okay? Whenever you have very high frequencies, at the time we are going for this topic. So then, with this, this concept is completed. So just 15 minutes, okay? Take the break. After 15 minutes, within 1 hour, we complete the questions based on this. So after that, we'll take a break for 45 minutes. Then we'll immediately start the